everybody, and welcome to Echo Live. My name is Anna, coming to you from the Michigan Science Center's Echo Distance Learning Program. Today, we are going to talk about scale models and 3D printing. Now, this is a somewhat innovative field of engineering. Only recently have 3D printers become really accessible and available for people to use. And when I say for people to use, I mean anybody can learn how to 3D print. Not just scientists and engineers and inventors use 3D printers. This is a pretty novel invention. So 3D printers have actually been around since about the 1980s, but recently we've invested in the technology, which has made 3D printers very widely available, and the software has gotten really easy to use. So we're going to talk about what goes into a 3D print. We'll talk about some design software. We'll talk about scale modeling and what that has to do with 3D printing. But before we get started, of course, as always, if you haven't done so already, go ahead and check in with us in the chat feature. You can go ahead and introduce yourself there. Tell us who you are, where you're watching from. Maybe tell us if you have any experience with 3D printers or 3D printing software. I'd be curious to know what you guys already know about 3D printing. And of course, you can use that chat feature to communicate and ask and answer questions with me throughout the entire program today. So first, let's talk about what scale modeling is, or what we mean by using a scale. Now, we've probably stood on a scale before, right? Something that tells us how much we weigh, maybe at the doctor's office or somewhere else. But we're not talking about that kind of scale. We're not talking about the scale that measures how much we weigh. We're talking about a scale like a ruler or something like a tape measure. So there's a little bit of math that goes into scale modeling. This is an example. Let's go ahead and talk about our first example here of using a scale as it pertains to a map. Now, I remember back in elementary school learning how to use a scale on a map, or using the legend on a map to calculate distances. If this is something you haven't yet learned, it's a great way to practice. Now, we are going to practice together calculating the distance between Detroit, where the Michigan Science Center is, and Kennedy Space Center, which is way down here in Titusville, Florida. Now, if we wanted to know the approximate distance from those two stars on the map, we're going to have to use the scale, which is noted right over here. I've also typed it out in words. So according to this map scale, 1 inch equals 375 miles. So for every 1 inch on the map, that means 375 miles across the actual country. Now, before the program, I went ahead and measured, and the map distance between these two red stars, let me go ahead and annotate that for us. The map distance between these two stars, how do I draw a straight line? There we go, is about 4 inches. And so that we can put into our scale to calculate what is the approximate distance between these two stars, or these two cities. So if we're going to set this up, we would need to set it up using some math here, or what we might call a ratio. So if 1 inch is equal to 375 miles, we would put both of those measurements on this side of our equation. The other side, we would type in what we know. So we don't know miles, but we do know inches, which is our top value. So on this side of our equation, we'll write what we know, which is 4 inches, but we're unsure about this bottom number. That's what we're trying to solve for. So it takes a little bit of algebra, but I promise this is something that, with a little bit of help from maybe an adult or an older sibling, you can figure out this math too. Now, all we need to do is do some multiplication in order to figure out the answer to the actual distance between Detroit and Titusville, Florida. So we would cross multiply, meaning we would take the numbers that are across from each other and figure out how they equal. So let's go ahead and do that together. So 4 times 375 is equal to 1,500 miles. And 1 times x is just equal to x. So we've already solved for our equation here. So just by multiplying across, we've solved for our unknown value The approximate distance between Detroit, Michigan and Kennedy Space Center down in Florida is about 1,500 miles or 1,500 miles. But this is a good way to practice. So if you have a map around your home, go ahead and practice using this skill. But we can also use scale, this object of equating two distances, in 3D modeling as well. Let me clear my drawings here. Now, you might have seen something like one of these 3D models before. So artists will actually create 3D models of real cities or other projects as well. And this helps us to get a good visual of what these objects or items might look like before we build them in large scale. So it can go either way. We can start from a scale model as a prototype, or we can start from something large and create a scale model of our own. So we're going to practice creating a scale model using something very, very simple. So we're going to create together a scale model of my distance learning table, my handy dandy, really beautiful wood table that I have here. We're going to create a scale model. And so all we need to do is set our scale. If you were to recreate this activity at home, you only need a few materials. You would need something like a notebook or a sketch pad where you can create a drawing. Raul has talked to us about sketching a lot when we're talking about inventing and putting our ideas down on paper. That sketching is a really important part of the invention process, but it's also a really important part of 3D modeling as well, as having a visual representation of what we're trying to create. So I have a lab notebook here, and I'll zoom in so you can get a better look at it in just a minute. You'll need something to write with. You'll need a ruler or a tape measure, works even better. And then some materials to build your scale model out of. And so I have cardboard for my scale model pieces. Now, let me give you a zoomed in look at my lab notebook here. So what I've done is I've just drawn or sketched out what I think my distance learning table looks like. But this is not a scale model itself because I didn't actually measure anything on this page. It's just here to help me record my data. So if I go ahead and set this here, maybe it'll even hold up on its own. Perfect. What we're going to do is we're going to take some measurements of my table and then we'll set a scale together. So we're going to measure my table in terms of length, width, and height. So length on this table is about 4.5 or 4.5 feet. So we'll go ahead and let's write that down on our journal here. So length equals 4.5 feet. Next, let's measure width, which is the distance between where I'm standing and the front of the table. Width equals 2 feet. So we've got 2 feet wide. And then height is the distance from the ground to the top of the table here. So one last measurement for us to record. And the height of my distance learning table is about 3.5 or 3.5 feet. So now that we've done our measurements, we'll decide on a scale. So in our map example, we had 1 inch represented 1,500 miles in real life. That's a pretty large jump in a scale. I'm thinking for this one, it would be easy if we could represent 1 foot as 1 inch. So we'll write that on our page as well, and then I'll give you another look. So we'll write the scale of this model is 1 inch equals 1 foot, which should make it really easy for us to recreate our model together. Go ahead and I'll show you how I recorded all my data. So it helped me to actually draw all of these dimensions in almost a 3-dimensional way. So remember my distance across the front of the table, that was length, which I noted with an L. Width was the distance from the back to the front of the table. We said that is width, and that was equal to 2 feet. And then height is how tall the table, which was 3.5. So all we need to do is translate that into our consumable materials. You can do this really easily just by taking something like cardboard or cardstock, or you could even use modeling clay to create a 3D model of any object inside your home. Starting with something simple like a table is a really easy thing to create a 3D model of, but you can create a 3D model of anything in your home using the same process. So all we need to do is decide, if I decided I'm cutting out the top of my table from this piece of cardboard, I would need to measure, according to my notes, the length of 4.5 inches, which is going to be equal to 4.5 feet on my real table. And just mark that with our pen. And then the width we said was 2 feet. And then you just cut that shape out of your cardboard. All right, so we have the top of my table here, which is really, really tiny. If we think about the scale, right, we set 1 inch equal to 1 foot. And since we know that there are 12 inches in 1 foot, our scale model is going to be exactly 1/12 the size of my actual distance learning table here, which is pretty cool. All right, the next thing we said we needed is the height, right? And so to cut legs, I just need to measure a distance using my tape measure here of 3.5, which is how tall we said our table was. Mark that on my cardboard. And then for this one, I'll need to cut 4 legs. And so I'm just drawing a line and cutting 4 table legs that are 3.5 inches. 1, 2, 3, and 4. Now, all we need to do is attach these together using some tape. And then, of course, if you were creating a scale model of something inside your own house, you might want to decorate it to look just like the object that's actually sitting in your home. And so I could create the front placard by creating a little label for it. I could create, so I would have to take measurements of it, right? And so you can customize your 3D models of the object that you are deciding to model inside your own home. This is a really easy activity, but it actually does a great job of showing you some of these engineering design processes that engineers use when they are doing things like 3D printing for real with 3D printers, because the printer doesn't know on its own what to print. We have to tell it. Now, does anyone remember how we said on a previous episode of Echo Live? Does anyone remember what we said we have to do in order to communicate with a computer or a machine? Something like our 3D printer here, which is definitely a computer or a machine. What did we say, or how did we say we're able to communicate? Using what? Does anyone remember? I'll give you a hint. We had a pretty cool dance party all about it. Tell me what you think in the chat while I put my finishing touches here on my mini Echo Distance Learning table. We definitely use science, Justin. You are absolutely right. That is never a wrong answer here on Echo Live. But we said that we use code. Robots or computers only know what to do when we tell them, right? And so the way we communicate with them isn't just by yelling at them, give me a table. Doesn't work like that, right? Computers are getting smarter and smarter, but we need to tell it in code. All right, so here I've gone ahead and I've created my own 3D model of my distance learning table. If you guys could see how tall it is in real life, you'd realize that these funny looking long legs are actually pretty accurate. I think if I wanted it to look actually like my distance learning table, I might need to even add the little front label to the front so it could say Michigan Science Center. And maybe I would even add something like a 3D printed Anna to stand here behind it. But I highly recommend you try this activity at home. Pick an object in your house, maybe a piece of furniture or maybe a toy that you have, and try to create your own 3D model and show it to us on Facebook or on Instagram or somewhere else. But now let's start talking about how this applies to the 3D printer, because the 3D printers have really revolutionized the way we build models and prototypes. So instead of having to build them by hand like I just did, 3D printers make this process much easier. So I'm going to get my printer started. I started a project earlier, but I wanted to see if anyone had a guess about what we might be printing here on top of the pad. So I've half started a project, and then the nice thing about this 3D printer is that I'm actually able to pause it halfway through the project so I can resume it in just a moment. Tell me what you think I am printing. If you have a guess, go ahead and let me know. And now I'm going to go ahead and get the printer started again. Dun, dun, dun. Let me make sure it can see me. Go back. Here we go. All right, so our 3D printer is off and running. But let's talk about how this 3D printer actually works. So if you do have a guess about what you're seeing us print, keep typing it in the chat. Maybe the more it prints, the easier it will get to guess. But 3D printers are pretty amazing. They create designs using what we call an additive process. So whereas if I were to take something like modeling clay or clay for sculpting, right? I could create a shape, but this is what we would call a subtractive process. I would slowly remove dough or clay in order to form this into the model that I'm trying to create. 3D printing actually works the exact opposite. It doesn't take any material away, it only adds it. So modeling with clay is a subtractive process by taking away the parts you don't need. This is an additive process. 3D printers usually print with plastics. So there is a spool of plastic right back here. You can even see it. This spool of plastic comes out like a long wire that we call a filament. That filament then travels through this long hose down to the nozzle, or what we call the print head, where it gets really, really hot. So the print head, if we take another close-up look here, this moving piece down here is actually quite warm. We heat it to a certain temperature so that it's able to melt the plastic. And then it comes out the end and it just stacks it in layers. Maybe at this really up close angle, maybe people even have a better guess now of what they think we might be printing. But this printer works on those same axes or dimensions that we talked about when we were modeling our table. It has to know the length, the width, and the height of the object that you are printing in order to turn it into that object for you to physically hold. Now, we said that 3D printers have really revolutionized engineering. It's made this process much easier, much faster, and much less expensive than it used to be. Where it used to take months and probably tens of thousands of dollars for people to get a prototype, just one example of what they're trying to work with. Instead of taking months and hundreds of thousands of dollars, we can have a prototype designed and ready to print in just a couple hours. And printing something about the size of this object here, I won't tell you what it is just yet, but this object in materials and electricity probably costs us less than $5 to create. So it's really made this process easy. But we don't just print with plastics. We can also print with other types of materials. So here's a couple more examples of scale models. So if you wanted to do something besides modeling a piece of furniture in your house, you could even create a blueprint, a scaled blueprint or 3D model of your house with all the different rooms and maybe even some furniture inside. Again, this is a really good way to practice on paper before you get to the online coding that comes into 3D modeling an object for 3D printing. 3D printers have allowed us to print medical devices. This is actually what we would call a bionic ear. So it was 3D printed in order to be a prototype for something you could actually implant for someone who has lost their hearing or has damaged the physical structure of their ear. Scientists are working on 3D printing entire organs by laying down a structure with a 3D printer and then actually 3D printing cells. So instead of using plastic, we can actually 3D print cells onto a structure that we build so that we can actually 3D print things like kidneys or livers or even heart valves for people who need new ones. Because right now, if we needed a new organ, we would have to get them from someone else. So we can 3D print things like tissues, but we are also revolutionizing the field of prosthetics for people and for animals. You know, prosthetics can be extremely expensive, especially well-made ones. But since 3D printing is so inexpensive and the material is really easy to come by, we're actually now 3D printing prosthetics for dogs like this one who don't have the use of their front paws. And so because of this, we're actually able to make these prosthetics very, very quickly. And for people, it's even more important because a long time ago, we used to have to wait. Kids would have to wait until they were fully grown to get a prosthetic because 3D printed or because prosthetics are expensive. And so you only want to have to buy one in your lifetime. Since 3D printed options are so much less expensive, we can actually 3D print them for kids and give them more throughout their lifetime as they grow. Because as you grow, you need a different size prosthetic, whether it's for your arm or your leg or one of your organs or a different body part. But 3D printing makes it so easy and so fast that we can actually 3D print multiple prosthetics for people over the course of their lifetime, which is truly life-changing. Now, of course, we use 3D printers not just in the medical field, but also for automotive industries and technology as well. If you live here in Michigan, like I do, the big three auto companies are heavily invested in using 3D printers, not just for prototyping, but also for 3D printing car parts, which actually go in real cars. They can be much less expensive to produce because we can make certain things out of plastic. They can become much more lightweight. And so this process is revolutionizing the auto industry as well. Just down the street from the Michigan Science Center is Ford Motor Company, who actually uses the largest 3D printed part in any one of their vehicles, out of any car that's actually commercially driven by people around the world. Now, Ford also has a lot of their designs, car designs or chassis available for people to download and 3D print on their own. So let's talk a little bit about the basics of 3D modeling using a computer program. Now, there are all sorts of computer programs out there for 3D modeling so that you can send your design to a 3D printer like this one. The easiest one that I think there is to learn on, the easiest program to learn if you are a beginner at 3D modeling, but you are interested in the process, is called Tinkercad. So Tinkercad is by the same people who make Fusion 360, which is the program that most engineers use and scientists use as well. But Tinkercad has a version, or Tinkercad is the very, very user-friendly version for beginners. Now, it has all sorts of pre-made shapes that you can just drag and drop onto your coding board here. So this represents the platform that you would actually be 3D printing on, just like we saw with our 3D printer here. So what I did before the program is I actually labeled and pre-drew all the different parts of my Echo Distance Learning Studio. But we can show you how we did that just using these pre-designed shapes over here. So if we wanted to replicate my tabletop, right, we'd use something like a box. And then we could change the dimensions by typing in here to make it the same dimensions that we had recorded in our lab notebook. So we said that it was 4.5 or 4.5 inches long, which was our length. We said that it was 2 inches wide from front to back, and that it was, oh, I didn't give you this measurement, but it's about 1/4, 0.25. Oh, I wish I could type it on there better. There we go, 0.25. Might just be easier to drag it. There we go, tall. And so we have our tabletop. And then I already went ahead and I pre-measured our legs. So if we look at the height of these, they're already at 3.5 inches. And so you would just need to place them on your design board here. Ooh, we didn't want to do that. We would just need to place them how we think they're arranged on our actual table. We don't want both, we just want one. And then once we're done doing this, we can very easily merge these shapes together to we just grab everything. And Tinkercad has all sorts of tutorials. So if what I'm showing you right now doesn't make a whole lot of sense, I totally understand, because new softwares can be tricky to learn. But the nice thing about Tinkercad is that they have all sorts of online tutorials that you can try or that you can use to go through this modeling process on your own. And so now I think that looks just about like my table actually looks right here in the studio. Now, once you've designed something in Tinkercad or one of these other 3D modeling programs, then you actually want to print it. Now, this is the design program, but this is not actually the printing program, because we said what's happening in our 3D printer is that this is reading code. We don't actually need to write any code. These programs will do it for us. But what this printer needs to know is how it should print this layer by layer by layer. Let's take another up close look, and maybe people have another guess, or maybe you're becoming more sure. I saw lots of good guesses coming in for what we might be printing here. But if we look as close as possible out the end of our nozzle there, it's actually printing this plastic in very, very small, very well-defined layers. So one at a time, all the way from the bottom up to the top. And so after you design something in Tinkercad or another modeling program, you have to send it to what we call a slicer or a slicing program, which is also really cool. The slicing program that I use for my 3D printer is called Cura, and it does pretty much all the work for you. So let's take a look at Cura. So this is the Cura program here. And if you haven't guessed already, this is the object that I'm printing. Let's see, does anyone think they got it right? Does anyone know what it is now, if you didn't know already? So just by right-clicking and holding my mouse, you can get an up-close look of what this object will actually look like right here on my 3D printer. So the nice thing about Cura is that you can actually tell it what type of printer you are using, drop in your design. So all I did was upload this shape from Maker or from another making program or 3D modeling program. And then, like we said, this does all the work for me. It can even do the work of scaling. So once you've designed your shape or object that you'd like to 3D print, but let's say this object is a bit too large. This is actually a bit larger than the object that I'm really printing down here on the table. So if you wanted to scale it, you can even use the features on this slicing program to scale it by a percentage. Let's see, I'm pretty sure it's that one, but there we go. So let's say I wanted it to be about half this size instead of that big, because of course, with a 3D printer, the larger your object, the more plastic it takes and the longer it would take. And the nice thing about Cura is that it also tells you exactly how long your print is going to be as well. So if we go ahead and click the slice button, takes just a moment to think about your shape, and then it's giving us an estimate that this shape would take about 42 minutes for the 3D printer to print. Let's take a look at that in a preview. Now, it doesn't look much different, but what's really cool is that once you've sliced your object, this is actually showing us what your object is going to print like in order. Using this layer over here, this actually tells us that it's printing it in 357 layers. 357 layers just to make this tiny little model rocket. Lots of people could tell that it was a rocket, hopefully because you watched our model rocket anatomy class last week here on Echo Live. But if we drag this bar down, we actually watch our rocket disappear. Let me see if I can get a better look at that. The zoom features can be pretty difficult to use, but let's see, maybe if we click this one here. All right, now, so this shows us the first layer of our model rocket. And as we climb, this is simulating all 357 tiny little layers that go into printing just this one model rocket. Now, before I scaled it down in size, I had actually exactly measured this 3D printed rocket so that I could fit one of those rocket engines that we talked about last week here on Echo Live. And so using my full scale model, which takes just a bit longer, a little over twice the amount of time to print this size rocket. This one has the appropriate size opening in it that I can actually add in those different parts of our rocket anatomy. I can add in our parachute and our wadding and our rocket engine, and I can actually launch this one using my rocket launcher that I showed you guys last week. Now, we're going to let our rocket continue printing here. We're about we're a little over 90% of the way done. And so it needs just a few more minutes, but I'd love to hear if you have any questions about our episode today, about building a 3D model of something in your home, about 3D modeling software. If you do, go ahead and let me know in the chat. I'd love to answer a few before we head out here today. Reminder that that program I showed you is called Tinkercad. It is a free online program, so anyone can use it. You don't even need to download it. You can do it completely online, and you can also drag and drop all those different shapes. You can build anything you want, and they also have links to find a local 3D printer. So if you're not sure where you can find a 3D printer, the website Tinkercad has links of where you might be able to find one locally, either at your library or another local place. If you can't find one that's close to where you live, they also have an option to have them 3D print your model for you, and they'll ship it to you. So you would just need to pay for them for the materials and time that it takes for them to run your printer and to ship it to your house, but you can design virtually anything. Now, we said that this process is super easy. I will not be launching the rocket today. That's a good question. I will not be launching the rocket today, but maybe we can do that on another episode of Echo Live. And if not, I'll take a video of it and I will post it so that everyone can see it. So the link to Tinkercad just went up in the comments as well. So if you are wanting to try to tinker around with that, try to model your own designs or toys, like I built these tiny little 3D printed tops. And I even went through a few iterations. So we said that this process makes it easy to make changes and modifications as you go. So I have all my different iterations of my spinning top here. So I started with these two. And I kept designing it just to get it to work even better. This one is the heaviest, and so it actually spins the best. Or this one is the heaviest, so it spins the best. But you can use them to make simple things like toys. But of course, scientists and engineers are using them to create really amazing things as well. Justin asked, does the head, the feed line ever get clogged? And the answer is yes, not normally. 3D printers have come a long way. So if maybe you've done some 3D printing in the past, you might have run into some problems with it. Normally, you'll go through all sorts of tech settings. You always preheat your 3D printer. So it kind of like you preheat an oven. Preheating both the pad that you're printing on and the print head helps to kind of melt that plastic and dislodge it. But clogs, of course, can happen. But every 3D printer, if you were to purchase one for yourself, they come with a user manual. If something bad were to happen to your 3D printer, they're usually pretty modular. And so you can even replace the print head if you needed to. You could also replace it so that you can use different size filament as well. Let's see, someone asked, is 3D printing the fastest way? And I have to say yes. So 3D printing can take you from a model, like I just built of my Echo table in that program, so a 3D model online to a real 3D print in just a couple hours. It's a really fast process. However, there are limitations to 3D printing, right? If you wanted to print 100,000 of these, it might take a lot longer than it might take if you were to just use plastic injection molding. And so if you want to produce in mass quantities, other options might be your best bet. But if you are looking to hold a scale model of your design to kind of see what it would look like in a three-dimensional way before you scale something up larger, or if you just need one, this is inexpensive and it is probably your fastest option as well. Oh, let's see. I think our 3D model here is almost 100% of the way done. We're just printing the very tippy top of our nose cone there. Let me see if there's any last questions before we head out. Leslie says, great topic. Thank you. I hope this is something that you do try. I hope you try out Tinkercad. Let us know how it goes. Post your designs. If you'd like to model my Echo distance learning table, I'd be happy to send you some dimensions as well. Lots of people who guessed what our model was before it was done, and that is awesome. I think you guys remember our model rocket. So good question. Someone also asked about camp. So I don't want to cut off our screen here. I'll talk about camp just while our rocket finishes up here. If you have filled out our ECHO evaluation survey, which is still live and you can still fill it out for the rest of this week, and you selected that you wanted to enter for a free week of virtual camp, you will find out on Monday. So we will announce the winner for our free week of virtual camp on Monday. If you are interested in winning a free week of virtual science camp with the Michigan Science Center, fill out that survey. It has been linked on our last few videos. You can find it on our website. We'd love to know what you think. Give us your feedback. And of course, you can win a prize, which is even cooler. And perfect timing. Thanks for all the questions, you guys. Our 3D printed model rocket is complete. So all we would need to do now is I'm going to let it cool for just a moment here. That way the plastic we know is totally hardened, and then we're just going to take it off of our modeling tray while I give it just a moment to cool. Couple reminders, of course, let's start with this one. Thank you to Ford Motor Company. They're making amazing advances in 3D printing, but they are also sponsoring ECHO Live along with Denso. They allow us to bring these programs to you for free every weekday until the end of June. Once we get through June, we will still have ECHO Live, but we will also have My Size Spark Camp, and you can win a free week of My Size Spark Camp by filling out that evaluation survey, which has been linked on our last few videos. Let me see if I can pull my tape off here. Our tape is really, really stuck to our platform. Oh, let's see. You probably want to watch me do this. So you can see that I'm just pulling the tape. And the only reason we put tape on here is just so that our design doesn't stick to the printing pad itself. It's designed to come off, but we just have better luck if you use this blue painter's tape, which comes off without leaving any sort of residue on the printing pad. So just best tips and tricks. I'm not sure how many people have a 3D printer at home. If you are interested in taking a workshop, like I said, visit Tinkercad. They've got all sorts of suggestions for places where you can take a workshop. There we go. And they will actually teach you how to make these things and print them using their printers inside their own studios. All right, our fins on this one are super delicate, so I'm just trying to be very, very gentle with them. And you might notice that there's a big difference. Let me zoom in over here on our table. There's kind of a difference between these two models, and it's that this one has this weird bottom section to it, but that's just support structure. 3D printers have to print on top of something, but that is designed to just peel off your support structure, and now we've got a 1/2 scale model size, or 1/2 diameter scale size model of our larger model rocket, which is pretty cool. So thanks for sticking with me the last few minutes here while our rocket just finished up. It's been so cool to teach you guys about 3D printing. I hope you'll give Tinkercad a try. I hope you'll try building a 3D model of something in your home and let us know how it goes. Otherwise, we'll see you back here tomorrow with a very exciting episode of ECHO Live, where we are going to talk to an expert from the Belle Isle Aquarium, just downtown